Climate change is a global challenge that has no borders, and to combat it requires coordinated work by all countries. Climate change rapidly warming up the earth and altering the marine life ecosystem. The abundance and the distribution of the harmful algal bloom species is increased due to this effect, which is coastal development and also eutrophication. This article generated a 50-year study which is from 1960 until 2009 time series of diatom and dinoflagellate using samples from continuous Plankton recording survey in Northeast Atlantic and also North Sea. Based on analysis and using Granger tests, the switch of the relative abundance is driven by an interaction effect between increase in sea surface temperature and also increase in windy condition in summer.
About 90,000 samples were taken from the continuous Plankton recorder survey for 50 times years series from the 1960 to 2009 in the Northeast Atlantic and North Sea. The CPR survey is the longest multi-decadal Plankton monitoring program in the world. It does not sample very close to the water and hence it will not reveal locally specific patterns of plankton change. 12 diatom and 9 dinoflagellate taxa were examined in the Northeast Atlantic region. It was selected based on the three criteria. Firstly, only taxa abundant enough to reach a threshold maximum abundance value were selected. Secondly, the species needed to be present on more than 4% of all samples. Third, only taxa that were first identified between 1960 to 1963 and were persistently presented until 2009 to examine the long-term changes in distribution. The detailed spatial trends for 6 abundance taxa were examined for every 5 years by ordinary twin gene using R and packages PP and G stack. The climate change was analyzed by using sea surface temperature. The data was supplied by the Hadley Centre of the UK Met Office. The second climate data was the monthly mean summer surface scalar wind speed, which is supplied by the International Comprehensive Ocean Atmospheric Data Set in the Northeast Atlantic from 1960 to 2009. To find a significant correlation between mean annual abundance for many taxa against either sea surface temperature and summer surface scalar wind speed, the Shelton method was used for serial autocorrelation.
The present warming of the Northeast Atlantic region is favoring warmer water species at the expense of cold water species with consequent range extension and contraction respectively. We consider dinophysis species is an example for mesotrophic harmful algal bloom dinoflagellate and Nautiluca cinchitillae as a heterotrophic dinoflagellate. Based on figure 1, a pronounced change in the relative abundance of diatom against dinoflagellate. During 1960 until 1980, dinoflagellate is more abundant than diatom in CPR sample, but this pattern has been reversed in past decades. Harmful algal bloom species have increased in frequency and intensity and become more widespread, and there is a broader switch from dinoflagellate to diatoms. For example, Serratium furca and Protoperidinium species have become more increased compared to previous level.
Based on Table 1 and Figure S1, the integrated dinoflagellate abundance show negative correlation with both SST and SSSWS. The shift from dinoflagellate dominance to diatom dominance is expected due to the increase in surface wind since 1960, which encouraged turbulence. Since diatom favors rough seas, they become dominant. Besides, diatom have numerous psychological advantages compared to dinoflagellate, which include high growth rate, high photosynthetic rate, and ability to survive in low nitrogen concentration region.
The shift in abundance and distribution of diatom and dinoflagellate is expected due to hydrological changes caused by the climate change. This also could be the reason for increase in HAB species. Another factors that is thought to cause blooms of HAB species are ballast water transport, aquaculture development, transport of seed stock, and eutrophication of coastal water due to human activities.
Using this range of statistical treatment, this study shows that both sea surface temperature and summer windiness were examples of important factors that alter the distribution of the diatoms and dinoflagellates in Northeast Atlantic and also North Sea.